Good afternoon, dear students. Okay, in yesterday class we discussed in the electrochemistry, the introduction of electrochemistry, the oxidation and reduction reaction, and galvanic cell or electrochemical cell or voltaic cell. And in today's class, I am going to discuss about, already we discussed Daniel cell. In today's class, I am going to discuss about the electrolytic cell, reversible and irreversible cell, and another the derivation of Nernst equation. Unit name is electrochemistry. And here, the electrolytic cell. Yesterday we discussed electrochemical cell. In today's class here, the electrolytic cell. In electrochemical cell means it is a conversion of chemical energy into electrical energy. Here the electrolytic cell is the conversion of electrical energy into the chemical energy. That is known as a electrolytic cell or electrical energy. It is known as a electrical energy. Here we take a beaker. This is a beaker. And here it contains two electrodes. It contains a electrolytic solution here. And there is the presence of electrode. These two are the electrodes. Here negative charge anion, and here the positive. Here this is a cathode and this is a anode. This is a positive charge. This is a positive charge. This is a anode. Okay, this end is a cathode and this end is a anode. And this is a aqueous solution of electrolyte. Here this is a aqueous solution of electrolyte. Aqueous solution of electrolyte or the molten electrolyte or the molten electrolyte. The molten electrolyte, that is A positive ion and B negative ion. You consider A positive and B negative, that is the molten electrolyte. Here we are considering this is a electrolytic cell. This figure is electrolytic cell. Here we are explaining this figure, that is the electrolytic cell. This is the electrolytic cell apparatus, and here you take the aqueous solution of an electrolyte. Here in this figure you take an aqueous solution of an electrolyte or the molten electrolyte in a vessel. Here we are taking in this vessel the aqueous solution of electrolyte or a molten electrolyte, and the vessel and two metal rods are immersed into it. Here two electrodes are dipped are here immersed in this vessel. Here this is a beaker or vessel, and this connected to a battery. Here these two electrodes and is connected to this battery. These are connected to the battery, and here we observe that the positive and negative, the anode and cathode, that positive ions, here the cations, the presence of here cations, and here presence of here the anions. Anions is anode, cations here presence of cathode. Here the positive ions, that is the cations, move towards the cathode. Here the positive ions move towards the cathode. Here these positive ions move towards the cathode and these negative ions move towards the anode. Positive ions move towards the positive ions move towards the cathode and negative ions, that is anions, these are the cations, move towards the anode. Cl. Anode is a positive charge, and here cathode is a negative charge. Here cations are the positive charge. Here anions are the negative charge. Here the positive anions, sorry, positive cations are moving towards this cathode. Here this cathode, and here the negative ions move towards the anode and move towards the anode, and this is the explanation of electrolytic cell. Here the anions afterwards the moving takes place here towards the cathode and towards the anode, and the anions are reaching at anode. Here the anions are reached at anions. Here see here the positive ions moving towards the cathode and negative anions moving towards the anode. In moving towards the anode, after this moving towards the anode, and it is reached at the anode. That it finally the anions are reached at this electrode here. That is the anode, and this lose the electrons here. When these are touches this here, the reaching is completed, it reaches the anode, and here it loses the electron. And the cations here, the cations are reaches at this electrode, this cathode, and it gain the electron. And here the losses electron, here oxidation takes place, and here the cathode, the moving of towards positive cations to the towards the cathode after reaching of cations to a cathode, and here the gain of electrons. Here always the moving the anions move towards the anode, cations move towards the cathode, and anode is takes place a reduction. Here oxidation and here reduction. Oxidation means loss of electrons. Here the reduction means gain of electrons. At cathode, in oxidation processes takes place. In here the anode oxidation processes takes place. In cathode the reduction processes takes place. The reduction reaction is opposite. Here you taken that is A positive and B negative. Here the loss of electron at anode, the loss of electron at anode, loss of electron. Here B minus here the loss of electron, B plus electron. The loss of electron, and this is known as the oxidation. Oxidation. Okay, here in this cathode, it happens here reduction. Here reduction means the gain of electron. Here the A positive. A positive means here A positive plus 1 electron. A positive plus 1 electron, you get A. Here the gain of electron. Here gain of electron. It is known as a reduction. Gain of electron, and it is known as a reduction process. And here thus the redox reaction takes place on supplying the electrical energy. Here the supplying electrical energy. Here the redox reaction takes place, resulting into the decomposition of the substances. Here it results in decomposition of the substances. Anyone taken NaCl, and here the Cl minus, and here the formation of one electron is lost. Here Cl and plus 1 electron, Ne plus 1 electron, and sodium ion. Sodium metal is formed here. For this process, here the resulting of here the redox reaction takes place, and afterwards the supplying it is reduction reaction takes place, supplying the electrical energy resulting into the decomposition of the substances. And here the arrangement in which the electrical energy is supplied to bring about the redox reaction, which was the otherwise the non-spontaneous, that is to be bring out the decomposition of the electrolyte, is called an electrolytic cell. Okay, definition of electrolytic cell is the conversion of the electrical energy into a chemical energy. That is, electrical energy is supplied to the electrolytic solution to bring about the redox reaction is called as a electrolytic cell. Then write here the definition of electrolytic cell. Definition of electrolytic here an arrangement in which electrical energy an arrangement in which electrical energy supplied to the electrical energy is supplied to bring about is supplied to bring about electrical energy is supplied to bring about the redox reaction, to bring about redox reaction which observed or which was otherwise is a conversion here, which was otherwise non-spontaneous that is to bring about the decomposition, that is to bring about the decomposition of the electrolyte, decomposition of the electrolyte is called electrolytic cell. Okay, this is a definition of electrolytic cell. Arrangement in which electrical energy, here this is a arrangement in which presence of electrical energy is supplied to bring about redox reaction here. Electrical energy is supplied in this instrument here and to bring about the redox reaction was otherwise the non-spontaneous, that is to bring about the decomposition of the electrolyte is called as a electrolytic cell. Next, the difference between electrochemical and electrolytic cell. difference between electrochemical and electrolytic cell. Yeah, right. Electrochemical cell. And here electrolytic cell. Okay, this electrochemical cell. Here the electrochemical cell. First difference, this device converts chemical energy. Here the chemical energy is converted into electrical energy. Here in this device the electrical energy is converted into chemical energy. In the electrolytic solution it is supplied to the electrolytic solution to bring about the redox reaction. Here to bring about the redox reaction. The resulting is redox reaction. Here first difference, this device converts chemical energy into electrical energy, converts chemical energy into electrical energy, chemical energy into electrical energy. That is electrical energy is produced. That is electrical energy is produced. Electrical energy is produced as a result of the redox reaction. As a result of the redox, reaction taking place. Redox reaction taking place. And in this second, this is the first point here in the electrolytic cell. First difference, here this device converts electrical energy into chemical energy. That is electrical energy. Chemical energy, that is electrical energy, is supplied to the electrolytic solution to bring about the redox reaction. Here this device converts electrical energy into chemical energy. That is electrical energy. That is here is same here. That is electrical energy is supplied to the electrolytic solution. Is supplied to the electrolytic solution. Supplied to the electrolytic solution to bring about the redox reaction. To bring about the redox reaction. To bring about the redox reaction. This is the first difference. Second one, here the second difference, it is based upon redox reaction which is spontaneous, which is based upon redox reaction, based upon redox reaction, based upon redox reaction, based upon redox reaction which is spontaneous, which is spontaneous. See, this is a which is based upon redox reaction which is spontaneous, and here the redox reaction in the second difference electrolytic cell, the redox reaction is non-spontaneous in this case. In this case, the redox reaction is non-spontaneous. Second difference, in this case, redox reaction is non-spontaneous. Non-spontaneous. This is the second difference. And third one is, here the two electrodes may be used in solution. Here the two electrodes are used in a electrochemical cell of the same or different electrolytes. Here the two electrodes may be used in solutions of the same or different electrolytes. Same or different electrolytes. Here the two electrodes may be used in solutions of the same or different electrolytes. Electrolytic solutions. Electrolytes are electrolytic solution. Here this difference not different here, only the same electrolytic solutions are used. Here the two electrodes may be used in the solution of the same electrolyte or may be used in the same electrolytic solution. Here third difference, the two electrodes may be used in the same electrolytic solution. Same electrolytic solution. This is the third difference. Fourth difference, here in the electrochemical cell, here the electrode on which the oxidation takes place is called anode, and electrode on which reduction takes place is called the cathode. Here the electrode on which oxidation takes place, the electrode in which the oxidation takes place is called anode. And the electrode on which reduction takes place, the electrode on which reduction takes place is called cathode. Is called cathode. This is the electrode on which the oxidation takes place is called as a anode, and the electrode on which the reduction takes place is called as a cathode. And here the electrolytic cell, the electrode which is connected to the negative terminal. Here, see here, the electrolytic cell, the electrode which is connected to the negative terminal of the battery. The electrode which is connected negative terminal of the board, terminal of the battery, negative terminal of the battery, negative terminal of the battery, that is negative terminal is connected, that negative is a anode, and is here the negative terminal is connected to the, or the electrode is connected to the negative terminal, or negative terminal is connected to the electrode of the battery is called a cathode. Battery is called cathode. The electrode which is connected to the negative terminal of the battery. You connected here, the electrolytic cell. This is a battery is connected this type, and here this is a positive terminal anode. This is a negative terminal cathode. This is a anode in the electrolytic cell here. The electrode here, the presence of electrode here. These are the electrodes. These are the electrodes, and here which is connected to positive terminal. Sorry, negative terminal of the battery is called a cathode. Negative terminal is connected is a cathode. Then positive terminal is connected to the electrode. When is called the cathode, and the cations migrated, and the cations migrate means here moving, the migrate to it which gain electrons, here the gaining of electron is called as a reduction, and hence reduction takes place, and hence reduction takes place, here the other electrode is called the reduction takes place, and the other electrode is called anode. This is a difference. Here the electrode which is oxidation takes place is called as anode. The electrode on which the reduction takes place is called a cathode. And here the electrode which is connected negative terminal of the battery is called this cathode. Negative terminal of the battery is called cathode. Positive terminal of the battery is called anode. Here the cation migrates with which gain electrode. That here the reduction takes place, and that the other electrode is called as a anode. And next the fifth difference, and right here fifth one. Okay, fifth one. A salt bridge or a porous pot is required in this cell. Here, a salt bridge or porous pot, a salt bridge or a porous pot required, porous pot is required in this cell. Here, no salt bridge required in this. Sorry, fifth point. This is the fifth one. Not salt bridge is required in this case or in this cell. Here, not salt bridge is required in this case, and here a salt bridge or a porous pot is porous pot. Porous pot is required in this cell. The salt bridge is this like your I already shown in last class here. This is like a salt bridge, and here this salt bridge is not required for this cell or this case. These are the difference between the electrochemical and electrolytic cell. And next, the reversible and irreversible cells. Reversible and irreversible cells. See, the reversible and irreversible cells. In this, in our last class, we discussed the Daniel cell. Here, first is a reversible cell. Reversible cell. Okay, here in this case we consider in a reversible cell that we consider the Daniel cell. Here whose EMF, that is electromotive force, the EMF is ZLS. In this ZLS, and here the loss of electron takes place Zn plus 2 plus 2 electron. Zn plus 2 and 2 electron, and this is a half oxidation. Of oxidation reaction. Oxidation reaction. In a Daniel cell, you consider as Daniel cell. Daniel cell. Here, zinc is a loss of electron. This is a half oxidation reaction. That is, here the half oxidation reaction is a 1.09 volt. The whole process that is a 1.09 volt. And if two such cells here, if two, one is a zinc and another is a copper, you are using here in such an external EMF. Here, this is a EMF 1.09 volt, and the external EMF of 1.09 volt is applied, the cell reactions is stops. Here the external EMF 0.09 1.09. Here an external EMF is applied or is supplied. External EMF is applied. The external EMF is applied, then the cell reaction. The reaction here, the cell reaction is stops. And if it increases 5 decimal, and here increases 5 decimal, here it increases the 5 decimally behind that this one 0.9 sorry 1.09 volt. Here you are applying the external EMF of 1.09 volt is applied to this one here, and it increases the 5 decimally of 1.09 behind the 1.09 volt. That is, then the cell reaction is reversed. Then the cell reaction is reversal. Then the cell reaction is reversal. And such type of cell is called a reversible cell. Such type of cells are called reversible cells. See here, reversible cell. Here you consider a alien cell. In that alien cell, the gene is loss of electron is called off oxidation reaction. And here you apply the EMF is of 1.09 volt. Apply the external EMF of 1.09 volt. It is increases the 5 decimally, and here it stops. The cell reaction is stops, and it is reversed the reaction. The cell is reversed. Such type of reaction cells are called as a reversible cell. Okay, I stop here only. I'll continue in next class. That is irreversible cells. And another, the derivation of first equation for a electrode potential and measurement of EMF and what is meant by EMF. And definition of EMF. Thank you.